What if I told you that the most dangerous, the most stubborn fat in your body, like that hard layer wrapped right around your internal organs, could actually be commanded to self-destruct?
Yeah, it sounds entirely counterintuitive.
Yeah.
Almost like biological science fiction, really.
Right. And what if the trigger for that self-destruction wasn't starving yourself, but actually eating more of things like, dark chocolate and olive oil?
I mean, when you look at the actual clinical data,
Yeah.
it is just pure, verifiable biology.
Welcome to the deep dive. Today, our mission is all about cracking the code on visceral fat for you.
Exactly. And we've pulled together an absolute mountain of research for this.
Yeah, we have a randomized controlled trial from obesity, a dietary intervention study from Frontiers in Endocrinology, research from the University of Illinois and Wake Forest, plus a massive review from Cello.
It's a lot of ground to cover.
Yeah.
But it's vital because we're going to bypass that typical, eat less, move more lecture.
Right. Okay, let's unpack this. How does adding calorically dense foods send a biological self-destruct code to our fat cells?
Well, to understand the code, you first have to understand the target. For anyone listening, we need to clearly separate the fat you can see from the fat you can't.
Like the spare tire versus the hidden stuff?
Yeah, exactly. If you pinch your belly, that soft, jiggly layer just under the skin, that is subcutaneous fat. Visceral fat is entirely different.
Much deeper, right?
Right. It is a dense, hard fat stored deep within the abdominal cavity. It physically wraps itself around your liver, your pancreas, and your intestines.
So it's not just like a passive storage locker for extra weekend calories.
Not at all. Visceral fat is a highly biologically active tissue. It functions essentially as an endocrine organ.
Wow, an organ.
Yeah, but instead of producing helpful hormones, you should picture it as a toxic chemical factory. It sets up shop directly against your vital organs, and it's constantly pumping out inflammatory signals into your bloodstream.
Which is exactly why we're talking about this today. Having a toxic hormone factory suffocating your liver is the direct precursor to severe cardiometabolic diseases for you.
Oh, absolutely. Insulin resistance, high triglycerides, the works.
But as I was reading through the Frontiers in Endocrinology study, I realized something incredibly empowering. You don't actually need to bulldoze the whole factory to get healthy.
No, you don't. They found a magic number, the 5% threshold.
Just 5%.
Right. Researchers discovered that losing just 5% of your visceral fat area triggers massive, disproportionate improvements in your overall cardiometabolic markers.
For you listening, this is huge. It means you don't need to look in the mirror and see a perfectly flat stomach or, a six-pack to fundamentally change your health trajectory.
And it gets better. The study showed that even a loss of less than 5% made participants 4 times more likely to significantly improve their HDL cholesterol.
And that's the good kind, right? The kind that protects your heart.
Exactly. It also rapidly stabilized their long-term blood sugar averages, their HbA1c.
So it's a highly achievable target. But you have to understand the environment you're trying to change. I like to think of visceral fat as like a toxic roommate who constantly blasts loud music.
That's a great analogy. And the loud music is the inflammation.
Right. You don't have to formally evict them to get some peace and quiet. Just getting them to turn the volume down by 5% changes the entire environment of the house.
And the key here is that visceral fat actually requires that loud music to survive. It thrives on inflammation.
It feeds on it.
Yeah. That inflammatory environment impairs your body's insulin signaling, which in turn confuses your liver, essentially tricking the liver into overproducing glucose.
So the fat creates an environment that forces your body to feed it more. Wow, that's insidious.
It is.
If that's the case, we can't just rely on eating fewer calories to hit that 5% target. If visceral fat relies on inflammation to survive, we have to cut the power to the stereo. We have to shut off the inflammation.
Precisely. And that brings us to the actual biochemical signaling. The clinical sources point directly to specific polyphenols and antioxidants in our food.
Which act like a sort of software update for our cells.
Right, reprogramming the body's energy sensors.
But wait, I have to push back here, just as a proxy for anyone listening right now. If a calorie deficit is the absolute foundation of weight loss, which, the physics of our bodies demands, how does adding something heavy like extra virgin olive oil actually help? I mean, oil is pure fat.
It's a necessary question. While a caloric deficit dictates if you lose weight, the specific biochemicals in your food dictate how and where your body processes that energy.
Okay, so the quality matters just as much as the quantity.
Exactly. Let's look at the data on extra virgin olive oil, or EVOO. In a rigorous double-blind study, researchers placed two groups on identical energy-restricted diets. The only difference was breakfast.
Just breakfast.
Just breakfast. One group consumed soybean oil. The other consumed just 1.5 tablespoons, so about 25 milliliters of extra virgin olive oil.
And the olive oil group experienced 80% greater fat loss. I mean, that is a staggering gap for literally just swapping the type of oil in a pan.
It really is.
What is the EVOO actually doing inside the body?
It comes down to the high concentration of polyphenols that are unique to quality olive oil. These compounds actively trigger two specific biological pathways.
Okay, lay them on me.
First, they activate the AMPK pathway. Think of AMPK as your body's master energy sensor.
Right.
When the olive oil polyphenols flip that switch, it signals your body to stop storing energy and start burning fat for immediate fuel.
Oh, wow.
And secondly, it activates the SIRT1 pathway, which physically improves the mitochondrial efficiency inside your muscle cells.
So you aren't just burning fat, you're like upgrading the engines in your muscles to burn the calories you eat more efficiently.
Exactly. It really is a software update.
Now let's move to the one everyone is going to immediately want to try, dark chocolate. But I want to be clear for the listener, we are not talking about a standard milk chocolate bar from the gas station. Right.
Far from it, unfortunately. The clinical threshold requires 85% cacao or higher.
So quite bitter.
Yes. The sugar content must be minimal because the mechanism relies entirely on the concentration of cacao flavanols.
Right. And the clinical trials back this up beautifully. There was a 10-week placebo-controlled trial tracking endurance athletes.
Yes, a yellow one.
They supplemented one group with just 5 grams of daily cocoa, so that yields about 425 milligrams of flavanols, and it drove a significant reduction in their visceral fat.
And we see this across different demographics too, which is important. Another trial followed postmenopausal women.
Which is a group that traditionally struggles with sudden visceral fat accumulation, right? Because of estrogen changes?
Exactly. Consuming just 10 grams of 99% cacao daily resulted in a measurable reduction in body fat mass.
10 grams is basically just a square or two.
Right. The mechanism here is that these specific flavanols heavily improve insulin sensitivity while neutralizing oxidative stress.
So you're directly suppressing the inflammatory signals that the visceral fat needs to maintain its mass.
You're starving the fat of its defense mechanism, yes.
Okay, so olive oil and dark chocolate, or an easy sell. Let's pivot to something a little more green. Broccoli sprouts. Not full-grown broccoli florets, but the tiny germinated sprouts.
What's fascinating here is the sheer density of the active compounds. Broccoli sprouts contain 20 to 100 times more of a crucial precursor to an antioxidant called sulforaphane than mature broccoli does.
100 times more, that's insane.
Yeah, and sulforaphane is an absolute metabolic powerhouse when it comes to visceral fat.
So you're getting a massive concentrated dose from just adding a small pinch to a salad or a smoothie. What exactly is sulforaphane doing once it hits the bloodstream?
It seeks out and activates a protein called NRF2. You can visualize NRF2 as the master control room for your body's antioxidant and anti-inflammatory defenses.
Okay, I'm picturing it.
When sulforaphane flips the NRF2 switch on, it activates a vast network of genes that aggressively calm systemic inflammation.
And when that inflammation drops, the visceral fat becomes metabolically unstable.
Precisely. It loses its shield. Furthermore, sulforaphane signals the liver to slow down a process called gluconeogenesis.
Hold on, gluconeogenesis. Let's translate that for me. What is the liver actually doing there?
Gluconeogenesis is simply the liver manufacturing new glucose. So, new blood sugar from non-carbohydrate sources.
Ah, okay.
When your body is inflamed and insulin resistant, liver gets confused and constantly churns out extra sugar, which eventually gets stored as fat.
Right, it's panicking.
Exactly. Sulforaphane steps in and tells the liver, hey, we have enough energy. Stop making more sugar.
It's literally telling the liver to chill out and stop feeding the fat. That's incredible. And we see similar targeted signaling with things like blueberries and green tea, right?
Yes, absolutely. Blueberries contain specific compounds called anthocyanins. That's what gives them their deep blue and purple colors.
And the research indicates these anthocyanins actually upregulate the enzymes involved in lipid metabolism, meaning they physically increase the speed at which your body breaks down fat cells.
Exactly. And the green tea data is perhaps even more robust. There is a definitive 12-week randomized controlled trial from Japan focusing on this.
Oh, right, the one with the catechins.
Yes. Participants who consumed a green tea extract containing 583 milligrams of specific catechins, primarily one known as EGCG, saw dramatically greater decreases in their visceral fat area compared to the placebo group.
And how do catechins pull that off?
Catechins drive a process called thermogenesis, essentially increasing the amount of energy your body expends to generate heat.
Literally burning it off.
Right. But it didn't just shrink the fat. The researchers noted a severe drop in overarching cardiovascular risks.
Like significantly lower LDL cholesterol, the bad kind, and a drop in systolic blood pressure.
Exactly. It's a systemic benefit.
Okay, so we've consumed the olive oil, the chocolate, the sprouts, and the tea. We've introduced all these powerful software updates into our system, but those nutrients have to actually be absorbed, right?
They do.
And this leads us to the fact that there is a massive living ecosystem in our digestive tract that physically controls how much energy we harvest from our food. The gut microbiome.
The microbiome is the ultimate gatekeeper. The comprehensive review from the Scilab database on probiotics and obesity paints a very clear picture of this.
And what did they find?
When you analyze the gut flora of obese individuals and compare it to those with healthy metabolic function, there is a stark, measurable difference.
Different bacteria strains entirely.
Yes. Obese individuals overwhelmingly exhibit a higher ratio of a bacteria class called firmicutes and far fewer bacteroidetes.
Wait, why does that ratio matter so much? How can a microscopic bacteria dictate my fat storage?
Because firmicutes are incredibly, almost dangerously efficient at harvesting energy from the food you eat.
So they're too efficient. They extract every single possible calorie passing through the gut and just hand it over to your liver to store as visceral fat.
Precisely. They leave nothing behind. But the fascinating part is that this bacterial ratio isn't permanent. Introducing specific probiotic strains can physically alter this landscape.
So we can change the workforce in the gut.
Yes. For example, strains like Lactobacillus fermentum have been clinically shown to restore levels of a highly beneficial bacteria called Akkermansia.
And what about the physical lining of the gut?
Right, another strain, Lactobacillus plantarum, actively repairs the mucosal lining of the gut, lowers circulating cholesterol, and in models of high-fat diet-induced obesity can actually begin to reverse the metabolic damage.
And for you listening, you don't necessarily have to buy expensive, specialized supplement pills to get these. The clinical data shows that regular consumption of Greek yogurt is associated with a 21% reduction in abdominal obesity.
It's a huge reduction for a simple dietary swap.
Right. Low-fat cottage cheese is another fantastic vehicle. It's loaded with casein protein, which digests very slowly, keeps you satiated, and preserves your muscle mass, all while delivering those beneficial bacterial strains to your gut.
But introducing those beneficial bacteria is really only half the battle. They're living organisms. If we want them to thrive and outcompete the firmicutes, we must feed them their preferred fuel.
And that brings us to the crucial role of soluble fiber.
Yes.
I want to highlight the Wake Forest Baptist Medical Center study on this because the methodology is just so solid. They tracked over 1,000 participants over a 5-year period using CT scans.
And CT scans are the absolute gold standard for measuring that deep, hidden, visceral fat.
Exactly. No guessing with calipers. They found that for every 10-gram increase in daily soluble fiber intake, the accumulation of visceral fat was reduced by 3.7%.
And understanding the mechanism here is vital. When you consume soluble fiber, it doesn't just pass through your digestive tract as inert bulk. Your gut bacteria actually eat and ferment that fiber.
And through that fermentation, they produce short-chain fatty acids. This is the mechanism that ties it all together, right? They produce things like butyrate.
Exactly. Butyrate is a biological byproduct of fiber fermentation, and it is a potent anti-inflammatory agent.
So it fights the inflammation directly at the source.
It directly improves your cell sensitivity to insulin and aggressively neutralizes gut-driven inflammation before it can signal the visceral fat to grow.
Let me try a new analogy here to make sure we're visualizing this right. If your gut is a manufacturing plant, the probiotics, the beneficial bacteria, are the machines on the assembly line.
Okay, tracking.
The soluble fiber is the raw material you feed into the plant, and the end product they manufacture is butyrate, the chemical cooling agent that is pumped out to actually extinguish the visceral fat's inflammation fires.
That is a highly accurate way to conceptualize it.
Yeah.
The machines cannot produce the cooling agent without the raw materials.
And getting 10 grams of that raw soluble fiber is surprisingly easy. It's not about eating like sad bowls of dry bran. You can hit that 10-gram mark with just 2 small apples, some green peas, and half a cup of black beans spread out over your day.
Very achievable whole foods.
Right. Or one of the most efficient sources, chia seeds. You stir a couple of tablespoons of chia seeds into that Greek yogurt. They absorb the liquid, slow down your digestion to stabilize your blood sugar, and provide a massive dose of that fermentable fiber.
Quinoa and leafy greens act similarly. They provide the raw materials, keep blood sugar from spiking, and as a bonus, greens contain folate, which can help lower your stress hormone, cortisol.
So we have established how antioxidants send the shrink signal and how fiber fuels the gut to produce anti-inflammatory cooling agents, which leads us to the final piece of the puzzle, the dietary fats we consume.
Because surprisingly, eating the right kinds of fats can actually dictate where your body decides to store its fat.
Here's where it gets really interesting because the math doesn't seem to work at first glance. If I want to lose fat around my organs, how does eating fat help?
It sounds paradoxical.
Totally. Let's look at the avocado trial from the University of Illinois. They took 105 adults dealing with overweight or obesity and provided them with one prepared meal a day for 12 weeks.
A very controlled setup.
Right. One group got a fresh avocado integrated into their meal. The control group got a nearly identical meal, calorically matched, but without the avocado. The result: the women who ate the daily avocado experienced a measurable reduction in that deep, visceral abdominal fat.
But the fat didn't just disappear, did it?
No. What's crazier is that they saw a physical redistribution of fat away from their vital organs and out toward the safer subcutaneous areas.
If we connect this to the bigger picture, we have to look closely at the second half of that study's findings, because the fat distribution in the male participants did not change at all.
Wait, really? The men saw absolutely no redistribution from the avocado?
None. Zero. And this highlights a deeply important nuance in nutritional science that is often ignored. Dietary interventions can modulate fat distribution very differently based on biological sex.
Because of hormones.
Yes. Men and women have fundamentally different hormonal profiles governing how and where they store lipids. The combination of monounsaturated fats and specific fibers in the avocado clearly triggered a beneficial fat-shifting mechanism within the female metabolic environment that simply did not activate in the males.
That is wild. It really proves that nutrition isn't just a generic math equation. It constantly interacts with our individual biology.
Very much so.
But avocados aren't the only healthy fats doing heavy lifting here. What other fats do we need to prioritize to attack the visceral layer?
We must emphasize the role of fatty fish: salmon, sardines, mackerel, and tuna. These are incredibly rich natural sources of EPA and DHA, which are potent omega-3 fatty acids.
And we hear about omega-3s all the time, but why are they so special for visceral fat?
These specific omega-3s are vital because they directly reduce inflammation inside the fat tissue itself. But more importantly, they aggressively reduce fat accumulation inside the liver.
And the liver is essentially the metabolic gatekeeper for visceral fat, right?
Yes. If your liver is fatty and inflamed, it is nearly impossible to lose visceral fat. When liver fat improves, thanks to EPA and DHA, visceral fat almost universally follows suit.
That makes perfect sense. And you don't need to adopt a purely pescatarian diet to get there, right?
No, the clinical data suggests that consuming just 2 to 3 meals of fatty fish per week is sufficient to change that lipid profile.
And for anyone listening who is plant-based or, just doesn't like fresh, walnuts are an exceptional alternative.
Absolutely.
They're packed with polyunsaturated fats and a plant-based omega-3 called ALA. ALA helps calm those inflammatory signals circulating in your blood and simultaneously boosts the production of satiety hormones like leptin, so you naturally feel full and stop overeating.
Exactly. It is a multi-pronged approach where the food itself is doing the heavy metabolic lifting for you.
So what does this all mean? We have covered a massive amount of ground today.
We really have.
We learned that while achieving a calorie deficit is still the foundational physics of weight loss, your visceral fat is biologically active. It's a stubborn, toxic factory, and it requires specific biochemical signals to actually shrink.
Right, it needs the software update.
Exactly. By purposefully adding nutrient-dense foods to your daily routine, like 85% dark chocolate, extra virgin olive oil, broccoli sprouts, green tea, soluble fiber, and healthy fats from fish and avocados, you are actively sending a stand-down order to your body's inflammation pathways.
And remember, you don't need perfection. Just a 5% reduction in that deep belly fat pays massive dividends for your heart, your liver, and your everyday energy levels.
It really is a complete paradigm shift in how we view our diet.
It is. And it raises a profound, lingering question for you to consider as we wrap up today. We've just spent this time exploring how specific natural whole foods can actively communicate with your fat cells, sending biological codes that instruct them to shrink and heal. It's incredibly empowering.
Yeah.
But it forces us to look at the other side of the equation. If natural foods act as a biological code instructing your body to burn visceral fat, what kind of chemical instructions is a highly processed, artificial diet sending to your organs every single day?
Oh, wow.
Are we unintentionally programming our own bodies to hoard the very fat that harms us?
That is a deeply provocative thought, and one that is absolutely going to stick with me the next time I'm staring at a brightly colored box in the grocery aisle. Think of your next meal not just as a pile of calories to be burned, but as biological communication with your cells. Thank you for joining us on this deep dive. We'll see you next time.